All right, in this video, we're going to be continuing in section 2.2, and we're going to be talking about tangent lines. So as we've talked about in previous videos, a derivative has really a couple different definitions. When we're talking about derivatives, tons of applications, but generally a derivative is defined as an instantaneous rate of change. Big word, instantaneous. Instantaneous rate of change as opposed to an average rate of change, which also implies that it is the slope of a tangent line to the curve at a given point. So really two different ways we kind of want to view a derivative. It's an instantaneous rate of change. So this will have tons of applications moving forward. And it is a slope of a tangent line to a curve at a given point, which is the part that we're going to focus on today. There's a couple good activities on Delta Math for doing this. So I want to go over these today and help illustrate this second definition, the slope of a tangent line. So if we look at this first activity, this is just a visualization of what exactly a tangent line to a curve is. So what we're going to do here is you're supposed to just basically drag this second dot and make this line tangent to the curve. So at x equals 7, what we're doing essentially is just making a line that's tangent to the curve. You can see this is just like a zoomed in version of the box. You can zoom it in more, zoom it out, whatever you want to do. But what you're supposed to do is just simply drag this and create a tangent line. So if it were to look something like this, if we were to hit at 2 spots, that would be a secant line. But what we're trying to create is a derivative, which is a slope of a tangent line. So you're supposed to just do the best you can to make this line a tangent line, which I think that's pretty good there. Let's go ahead and submit this one. Not an exact science. So again, on this next one, we're supposed to make the tangent line at this point -3. So all we do is just drag this. You can go either direction. You can go this direction. This one's a little bit challenging as well. Or you can go this opposite way. And we're just trying to make this a tangent line. Now this one's actually going to end up sort of being on the exact curve there. Yeah, this one's kind of challenging. But what you could do is just sort of pull this and take it. I think it's going to accept it if it's just right on here. That looks good. All right, let's go ahead and submit that one. Not the best illustration on that one. Let's do one more here. All right, this would be a good one. So to make a tangent line, again, it's kind of hard to illustrate, but that's why we're doing this. Is tangent lines aren't the easiest to draw because it's almost impossible to draw a line that only hits at one spot. This looks pretty good. If you looked at the zoom in version, you're just trying to make a tangent line. That's all. All right, let's go ahead and look at the next one. We are now going to be calculating the slope of a tangent line. So if we're given this first function here, to calculate the slope of a tangent line, we're going to do two things. So slope of tan line, 2 steps. The first one is going to be actually to calculate the derivative. Calculate derivative. And then after we have that derivative, we're going to plug in the point. Plug point into derivative. I want to say f prime of x. That is one of the notations for derivative. All right, so pretty simple. Calculate the derivative f prime of x using the power rule. -6x just becomes -6 because we drop off the x. And 4 just goes away because the derivative of a constant is 0. So the derivative of this function is actually just -6. This one is a linear function, not the greatest example for our first one, but There's no place to actually plug in the 6, so our derivative at any point on this function is actually just -6. Meaning the instantaneous rate of change at any point on this function is just -6. All right, now this one actually uses the limit definition to calculate this. I did not make you do that here, so lucky you. I want to do another example. These ones are kind of bad here. This one. A little more interesting example. All right, here we go. This will be a better illustration of what's happening. So in this function, we have a parabola, 3x squared plus 4x minus 2. I don't know exactly where this function is, but let's say it's like, and it won't look exactly like this, but let's just say it's some parabola down -2. It looks like this, right? And so we're supposed to find the slope of the tangent line at x equals -11. So what we're finding is if we're to go out to -11, let's just say, oops, it's out here. There's -11. The slope of the tangent line would look something like this. Touches right there. So that's what we're trying to find. What is the slope of this line at that point? You might be thinking, like, why would I need to do that? Don't worry about why at this point. Just know that this is something that's very important for AP Calc. And we'll talk about why in future videos. So the slope of this tangent line at x equals 11, we do 2 steps. We find the derivative, f prime of x. That becomes 2 times 3, which is 6. X, subtract 1 from the power, so 6x to the first power, just 6x, plus 4, right, because the x drops off, and then the derivative of -2 is just 0, so that goes away. And then we just plug in -11, so f prime of -11. So it's just 6 times -11 plus 4, -66 plus 4, which is -62. So an extremely negative slope, which is kind of what I have drawn there. That makes sense, right? -62 slope. So that is going to be our answer. Let's go ahead and just do one more. This one's a constant. Constant ones are very easy. Maybe we'll do one more after this one. So you just calculate the derivative. It's just 6 in this case, right? So there's no place to even plug in that x, so the answer is just 6. The reason why is because this is just a linear function. Down here at -9 is where it crosses. Has a slope of 6. Looks like that. So any place where you draw a tangent line on this is actually just going to be the line itself, any tangent line of this, which means it's going to have the same slope as this. The slope of that was 6. So any tangent line is going to have a slope of 6 as well. That's what's happening here. All right, let's do this last one here. So we've got another parabola. Find the derivative, f prime of x. Hopefully you're getting good at this now. 2 times 11 is 22. X to the first plus 4. And then we just simply plug in -9. F prime of -9 equals 22 times -9 plus 4. Do that quick calculation there. 22 times -9 is -198 plus 4, so that'd be -194. And our last section here is going to be now actually writing the equation. So this one's going to take a little more time, but if you think back to some just basic algebra skills where you had to write an equation like given 2 points, that's essentially what we're going to be doing here. We have a function, -x² minus 5x plus 2. And I'm gonna actually just gonna go ahead and graph this so you can see what's happening here. -x². All right, as we know, that's gonna be a parabola. And will look like this. Oops, sorry, that a little crooked. All right, so downward opening parabola. X equals -4 is like right here. So what we are finding is the equation now, the entire equation of the tangent line at -4. So at -4, there's going to be a tangent line that hits this function exactly 1 point. So we're answering the question, what is this equation? Again, you don't necessarily need to know why you're calculating this at this point, but know that it is important. All right, so how we're going to do this is we're going to start by just like we did on the last one. We're going to start, so this would be equation tan line. We're going to start by finding the derivative. Calculate the derivative, so we're going to say find f prime of x. First step. So f prime of x is going to be negative 2x minus 5. Right? The next step, like we just did in the previous one, is to plug in the point. So to find f prime of our given point. So now f prime of negative 4, negative 2 times negative 4 minus 5 would be 8 minus 5, which is 3. This, think about the interpretation, this is a slope. That's going to be the slope of our tangent line. It's our m of our tan line. In order to write an equation of any line, you need a few things. You need a slope and you need a point. So now we have a slope. We almost have a point. We don't have an entire point. We have an x value, right? So what do we need? We need a y value. So the next thing we're going to do is we're going to plug our given x into f of x, our original function. Sorry, this is a little bit sloppy here. So we're going to plug the given x into our function to get y, and that's going to give us our y. So when we do that, f of negative 4, that's going to be negative 4 squared minus 5x plus 2. Oops, sorry, negative 5 times negative 4. That gives us negative 16 plus 20 plus 2. So that's going to give us 6. So that's saying the y value is 6, which makes sense based off of here, right? Looks like that's about 6. So our point here is negative 4 comma 6. So given that we know a point, we know that the slope of this thing is 3, we can now write an equation. So we're going to write an equation. Change to a different color. We're going to plug these into y equals mx plus b. So plug x, y, and m into y equals mx plus b. I'll try to write this better on the next slide. Sorry. So we're going to plug all the information in. Y equals mx plus b. We got a y is 6. Our m is 3. Our x is negative 4. The only thing we don't know is b, so we got to solve for b. That gives us 6 equals negative 12 plus b. Add the 12 over, it's 18. So b equals 18. So we got a b and we got an m. So our equation then is y equals 3x plus 18. I know there's a lot of steps going on there. This really is just adding 2 steps to something that you did a lot last year and in Algebra 2. If you had me for pre-calc, we did this at the very beginning of the year. We wrote equations given a point and a slope. Part of the reason why we did that is so that you can do this. You can write the equation of a tangent line in calculus. So let's go ahead and type that in, and then I'll show you a couple more examples. So that is the equation of this orange line that we drew. All right, let's look at the next one. Let me clear all this junk off. So again, this is a very important thing that you're going to be asked to do throughout the year, and with functions that are more difficult than these. All the derivatives we've done so far are very easy derivatives. We're going to keep doing harder and harder derivatives as we progress. All right, so equation of a tangent line. Our first step is to find f prime of x. So in this case, f prime of x equals negative 2x. The first power, the negative 2 goes away. First step done. Okay, second step is to find f prime of our given point, given x. So in that case, it's going to be negative 4. So f prime of negative 4. Negative 2 times negative 4 equals positive 8. And this is our slope. M equals 8. So very important piece of information. Well, the next thing we're going to need to find, if we're going to find this equation of tangent line, is we got an x, but we need a y coordinate. So we're going to find f of our given x. So now we're going to plug our given x into the original function. So f of negative 4. And some people like to do this step first just to get out of the way. It doesn't matter if you do this first or third. It doesn't matter the order, but you do need to find the y. So that's going to be negative 4 squared minus 2. This is going to be negative 18. So that is our y coordinate. So we got an m, we got a y, and we got a given x. Our x was negative 4. So we got the 3 pieces of information we need to write an equation. So we're going to plug our x and our y. So it would be x comma y and m into y equals mx plus b. So when we do that, we're going to get, that's step 4. Y, which would be negative 18, equals m is 8 times x is negative 4 plus b. So then we solve for b. Step 5, solve for b. In this case, b is going to be, say, negative 32, and that over would be 14. So b equals 14. That's the last piece of information we need to find. Final step is to, step 6, plug m and b into y equals mx plus b. So this is not difficult. It's just a lot of steps you got to do through. So this would then be y equals our m, which was 8x plus our b of 14. And this is the equation of our tangent line at that point. And if you can envision what's happening here, quick illustration. This negative x squared minus 2 would just be a parabola opens down at negative 2. So this is saying at negative 4, so this is negative 4 out here, the equation of the tangent line would be 8x plus 14. So it would hit up there at 14, right, slope of 8. That's what's happening. All right, so let's go ahead and type it in, and we'll finish off with one more example here, go a little bit faster. All right, so last problem. All right, this one has an extra, has a higher power here, so that's good. All right, I'm just going to go through it, not write out the steps, but just go through step by step here. So our first step is to find f prime of x. This is going to be negative 16, because 4 times negative 4, x to the third plus 12 x squared, right? 3 times 4 is 12 minus 1 plus 2x. That is our derivative. The next step, plug the given point 1 into the function. F prime of 1, negative 16 times 1 cubed plus 12 times 1 squared plus 2 times 1. F prime of 1, let's see, negative 16 plus 12 plus 2. That gives us negative 2. So that's our m. M is negative 2. The other piece of information that we need is a y coordinate. So we do just regular f of 1. Plug it into our original function. Negative 4 times 1 to the 4th plus 4 times 1 cubed plus 1 squared. That's going to give us negative 4 plus 4 plus 1. So that's just going to be 1. So y is 1. Okay, now we're going to plug this into y equals mx plus b. I do like to write out y equals mx plus b every time, just to make sure you plug it all in the right spot. So our y was 1, m is negative 2, our given x was 1 plus b. We solve for b. This becomes 1 equals negative 2 plus b. Add the 2 over, so b is 3. Now we've got all the information we need to write our equation. We've got our b, we got our m. So y equals negative 2x plus 3. The equation of our tangent line. And you can do that. You can do a very important part of calculus. All right, so that wraps up this video. Just as a reminder, there is always this extra help video here, which you can watch. I don't generally watch them, but sometimes they do have a little bit different way of presenting these. It does look like in this one, they use the point slope form instead of y equals mx plus b, which is another way to write the equation. So sometimes there's a different perspective in there. Feel free to watch those. Sometimes you can get a little bit different insight. Maybe it's taught a little bit differently the way that I teach it. Maybe it's even better. So use those if you need be. And as always, reach out to me if you do want some extra help, and I can arrange to meet up with you in person. All right, see you.